Yes, hello and good morning from Sweden. Welcome to our weekly blog. I am Arslan, one of the teachers, and where we will kick off the week by reviewing what we aim to accomplish and any significant event that will take place. So we have today Daniel, Tobias, Frederick. Yes, and as you know, as I mentioned last time, today is our live stream day. So Daniel and Tobias are preparing for a 3D workshop. And then we have TAs, Taj and Shashwat. Mm, so first of all, let's see where are we right now. As you know, there are lectures out there by Uksana about visualization, data visualization. And last week was about connectivity. And also, we had a bonus lecture last week from Joy. He is from Helium Foundation, and it was nice that he was here in last April and he recorded this lecture. So I hope you have seen these lectures, very interesting, and you can see how helium actually works. How do you connect with it? So after connectivity, the next part is visualization, the data, and you can, as you can see from this applied IoT roadmap, that you can either use low-code IoT solutions such as UB Data Cake or Adafruit, or you can go with a big data IoT solution such as Google Cloud, Amazon, or IBM. So Oksana has uploaded two lectures. One
Ja,
is
de drog nu
more
iväg.
about data visualization, or how can you, you can see the detail how things are working about this. And then second lecture is more about tools that you can use for visualization. So it's very interesting to see this discussion on lecture 8 with TAs. Please watch these two videos to get all the information you need. Another update is that quiz number 3 is out. So deadline is 24th of June. Please don't miss this quiz. And for quiz 2, the deadline is today until 5 p.m. So you still have a time if you haven't done it, because I can see from the vote channel that some students are doing thumbs down. I am assuming that maybe they haven't done it yet. So don't miss it and do it on time. And then see quiz number 3. It's about connectivity. First, you go and watch those videos about connectivity, and then I think it is very easy for you to do. And I can see on Discord that some students are still waiting to get their kit as or a specific sensor from ElectroKit. And I can see that how Jim from ElectroKit is trying hard to get all the hardwares you need. So shout out to Jim and thank you for his support. And I hope all students get their sensors and hardware as soon as possible. And I can also see from Discord that some students are still sharing their project ideas. Just a minute. Maybe just so from those project ideas, students are asking that what grade they can get. I think it's very hard to say right away what grade you can get. It depends on how much effort you have put in and whether you have completed all the parts from data collection to data visualization. Sometimes, I will mention this, students are aiming for A grade, but they might still can get C or lower if the project did not go as nicely as they planned. So there is a study guide TAs mentioned many times. I can share my screen again. Uh,
Okay, Arslan, we have now Oksana. We're just going to let her jump in
yes, yes.
and see if we can make her solo layout.
Oh,
So,
well,
Oksana,
I and Mr. Hamid here also, and
Hello everyone.
someone else. Sorry. Yeah, we are company is buying some last things for our trip.
Yeah, we're gonna buy an outdoor Ethernet cable to set up the gateway with. So now it's my turn.
Yeah. So we are on our way to Hässö, and we will be here during the whole stream, a bit on and off, showing what we do and how it's going. Unfortunately, weather is not at all on our side.
It's rainy all
and one thing we need to do today is install a sensor in the water. So hopefully there is a bus to there. So just keep an eye on us and put me back on stage when we're here. And see you. Won't interrupt you anymore.
Yes, see you at
thank you.
Yes, Fredrik, you are saying something.
No, and we could just explain that during this live stream day, we do have one team that is up in Västervik. So as you saw, Oksana and David and Hamed, they are out they're going to an island outside Västervik called Hässö, and they're going to install some sensors and a gateway and do some stuff. So we will see them jump in and out from the stream occasionally. And also we have the 3D printing workshop part that is, I would say, the main event of what is happening today. And we are also going to show a little bit of the lab and well, try to be a little bit flexible. This is a live stream day, so anything could happen, and maybe not everything will happen, but everything could happen, so to say. So we're now streaming from several places. Tad, Joachim, and Charlotta, where are you at?
Yeah, for one, I'm at home.
You're from home. And where is home for you, Joachim?
Just outside Stockholm. So a bit far from you guys.
Yeah.
Yeah, same here, Stockholm.
Of course.
I'm in Växjö, and I will probably have to go to the science park soon, but I'll still try to stay in the stream.
Yeah, and when you go to the science park, maybe you could also bring in some. You could show off a little bit of the 3D printings that is on the science park, if that is if you're available to do that stuff at the science park, because there is a good lab in the science park as well. Yeah.
Probably, at the very least, I could show maybe some of the stuff we've done, like the weather stations or something. We do have some interesting stuff, like we are currently building an open source 3D printer, because the last project of ours was an open source CNC machine, but then we sort of realized those are kind of the same thing. So hopefully they'll let me show that off.
Yeah. And just for all of you that are watching into this stream, it's fine to sort of just keep it on in the background and do something else if you're not super interested in what's happening. The main idea is now it won't be like a condensed lecture format. So don't expect that. This is something that we usually do to sort of informally try to do some educational material in a different format, in a different way. So the time plan for today will be that I would say in, let's say, about 10 minutes or so, we will introduce Tobias and Daniel, and they will start the 3D printing part, where they will go instructionally and talk about what a 3D printer is, and what they're going to do, and we're going to also look at some design to how to actually make your design. And at the same time, we also have the team from Västervik, so they might jump in, say hi, and I think that at about lunchtime, we hopefully will see some sensor installations, because I think they are now transporting themselves out to this island the next hour and a half or something like that. So my best guess is that about lunchtime, 12 o'clock, and from that we'll probably see more action from the the guys in Västervik. That's what I believe, at least. But we'll sort of keep it a little bit flexible and just try to, yeah. So what I could also say to you, if you want to interact with the stream, you could either do that in, like, obviously on the chat on YouTube. We will monitor that, but I would say we prefer if you do it on Discord. So use the channel live lecture questions, and we will monitor that at all times. So whatever you want to put in, if it's a question, if it's a request, or something like that, just do it, and we'll respond. I think you, Joachim, you also have like admin rights now to the stream, so you can change and adapt. So maybe you could take sort of also a little bit backseat role as like, yeah, we'll see how it goes. I think now that I'm going to see, I'll do it like this. I'll put myself in solo view. How does that work? Let's see.
I can do that.
Yeah.
Yeah.
Okay. So
yeah. I can see in the list there is smart lashing demo today, or
yeah.
Okay.
Exactly. So there will be a demo of a project that we have done as well. So we can start by showing the office space, because that's also an interesting thing for people that are not here. It's a distance course, but this is how my office looks like. That's my screen, and something that you also, it's not the best weather today, but you can actually see Kalmar Castle outside. So we have a very good view from the office. And now I'm going to take the walk to the lab, and my neighbor is
Hello,
Daniel.
Hey, Fredrik. Hello.
And
Welcome
you're going
my
to do?
So I'm going to be partly responsible for the 3D printing workshop today. So I guess we're walking that way, or?
Yeah. So let's walk to the IT lab.
Okay.
And what we could also, well, say is that, well, here we have Arslan's office. And Arslan, you can wave.
Yes. Hello.
Yeah. So we also have a puzzle. We usually do puzzles all the time.
And we have that. This.
Yeah, we also have a hockey game. So that's one of the things that you need.
Examinations.
Exactly. And it's not a long corridor, but we are now at the IT lab. So what we could do is that we could, maybe the cameras are, no, we don't have any overhearing. Yeah, okay. So here we have Tobias.
Yay.
And Andreas.
Hello.
Need to print the gimbal for you for the laptop.
Yeah,
the laptop cam.
but this works quite good. So, and we do have the setup now with a couple of 3D printers, and so. But we're going to change streams, and if you want to look at how this is from the other side, is that we have a computer streaming computer here. We have two, a good microphone, more cameras, and a lot of stuff here on the table. And I think they have some kind of filter on, so it's a little bit blurry in the background. Sorry for that, but it will be better very soon. So let's change the stream, and I'll mute myself, and then we'll unmute that one.
Mute. All right. Yes.
Okay.
Welcome to the 3D printing corner of things, but I think maybe we should go for the overhead cam instead. Where can I find that? Which one is it? That one, is it? Remove, no?
Yeah, move to the other cam. There.
All right.
Okay. So welcome to the 3D printing workshop.
Yep.
So we have already started a print, which is running behind me here.
Please zoom in a little bit. It's kind of dark.
And me and Tobias, we have been printing for a number of years. And I think one of the most interesting aspects of 3D printing is to
Solve something.
solve
a
problems,
problem.
everyday problems. So in this case, this is Tobias' design. And what kind of problem did you solve here?
I needed a stand for a laptop. So I needed something that could raise my laptop a little bit and keep it at a nice angle. So the screen is nice and I have my external keyboard and stuff like that. So I needed something for this. And sure, you can go out and buy, but that will cost me maybe 500 crowns. Instead, I made a little design looking like this. It actually took a few attempts to get the angles correct so that my laptop can balance nicely on it.
Nice.
And that's what we are printing also. I will remove this so I don't drop it.
Awesome. So I think that, could we please change the angle?
The angle on what?
The camera angles.
What do you want?
Yeah,
You
I
could
want to see me.
I want to see me.
And not just like, awesome t-shirt, but, so that
Let's
we can
zoom
talk about-
out.
Okay. So, I mean, there are a lot of different things we can print,
Definitely.
and some more useful than others. And I like to solve, these kind of everyday problems that you need to raise something, you need a small adapter for something.
Yep.
Something at home broke, and I can fix it at home with my 3D printer. So my shower, the doors from my shower broke, and there were these small wheels. And I just, measured the broken ones and drew them up.
Yep.
And then fixed my shower. And they have been working for, I think, like 6 years or so.
Yeah.
These new wheels.
It's remarkably strong, actually, this plastic.
Yeah. But there are also these more fun stuff.
Yeah, I think we should brag about the Hulk.
Yeah.
This
Do
is
a
actually
Hulk
a very, very cool print. And it's printed on a multi-material printer also, so it can print several different plastics in the same print. So that's pretty cool, actually. One of the cooler prints.
Nice.
But we can also print, really pretty large pieces. This is, of course, a very cool Stormtrooper helmet, I think.
It's quite roughly printed, this one.
Yes.
Right? In order to print it fast.
Yes.
We have also, every type of model here, well, like this, that is joined. This is print in place, right?
Yes.
So this has been printed in one piece, and then you just remove it from the print board, and it can move and articulate.
Yeah, that's pretty cool.
So in my work here as a university professor, I have been also using the printers for connecting to researchers. So this is a model of a building that one of the environmental health researchers here at the Linnaeus University wanted. So they wanted to be able to talk about their building before it was built. So we 3D printed this model of it so that they can place it together with other models.
Yeah.
So such things can also be done. Of course.
But what do our students do? We have students in the IT lab, and they usually don't print kind of like stuff like this. They print boxes for their projects, and maybe that's also what kind of like you will be doing if you have a printer. And I think this is a pretty awesome example of a cool box. It's a camera box for a Raspberry Pi that also has an inset for a Coral board. So that's pretty neat. And the camera is, it's a little bit detachable. And if we open things up, we can see that there's a Raspberry Pi inside. That's a typical kind of like project for IoT or something similar. That's being printed here in the lab. All right.
Yeah, so I think we're gonna try to start to print.
Yep.
So this printer, these are two Prusa printers here. They are very reliable, and of course when we tried it out just before this, it crashed. So we have had some problems with this smaller one.
Yeah, actually.
That I think it overheats or something like that. But I'm gonna start to print. And in this case, it's a print for solving an everyday problem for one of our colleagues. He has, I think it's a vacuum cleaner or something like that in his shed. and he needs an adapter between two different sizes. So it's like 100 millimeters down to 60 millimeters.
All
or
right,
so.
right.
And I've pre-drawn everything, and we're going to show a little bit on how to draw these in a more IoT box sense later. But I pre-drawn it today, this morning, together with him, and then I'm just putting it on an USB stick and putting it into the printer, and we're going to start it out. And now the printer is going to, start working with the file. Didn't crash yet. And the different things that this printer is doing right now is that it needs to preheat, so it needs to heat up. And the reason that it heats up is because we have plastic, and this plastic comes in these rolls.
Called filament.
Yeah. So and it's this how big is it? 1.75 millimeters or something like that. And it comes in these rolls. And when we heat up this plastic, it melts.
Yes.
So it starts to heat up, and in this case we have a plastic that needs 230 degrees or so in order to melt down into the temperature where it can be printed. So right now it's 160 degrees, it's going to heat up to 170 degrees, and then it's going to start moving.
You can actually take a look at what's actually the anatomy of a thing like this. So the filament goes into this thing, and we have a heating block with a heating cartridge, and this heats up this part and it melts out the plastic and pushes the plastic out of a tiny little hole.
So how tiny?
In this case it's 0.4 millimeters. Actually on that one we have a 1 millimeter nozzle, so it can print really a lot of plastic quite fast, but 0.4, 0.6 are normal nozzle sizes.
These go down to 0.2 or even smaller than that.
Yeah.
However, there are problems when it gets too small, that it's easily that you get some dirt that gets stuck in that hole, and then you fail the print.
And as you can see on this one, it has been through some rough times. It's pretty charred, and it's an old design also for these types of hot ends. But this is basically how it looks. And in some cases you see more or less of that looking at the printing heads themselves. All right, so we can melt plastic, we extrude this plastic, and we can put it in like layers on top of each other. How does the rest work, Daniel?
Okay, so the hot end, this one, sits on a robotic arm. So we have a number of motors that can move. So it can move, up, down, side to side, and back to front. Actually, the robotic arm is just moving up, down, and side to side, and then the print bed is moving back and forth. So we have 3 degrees of motion in this one.
And you can see this print bed moving here also, of course.
So actually the print bed itself also heats up. So we're waiting for it to heat up. It's 78 degrees right now. We're waiting for it to heat up to 85 degrees. And the reason for that is that we want the print bed to be heated so that the warm plastic can adhere to the print surface, and that you get a good adhesion. Think of it as you more or less it's glued to the surface as long as it's warm. But it's also the case that we want to make sure that the plastic does not cool down too fast, because it can.
You can take a look at
what can happen if
we are not stuck properly. You can see that this part was printed with this side on the bed, and it's kind of like very wobbly.
So one of the edges has risen up and broken loose from the print bed. So it's very important with good adhesion. So one of the things that we have not done today is that we put this is a way of a liquor. So now it starts moving.
It's a liquor. Alcohol.
Alcohol. Yeah. You don't drink this one. So you clean up the print bed before you start using it or start printing. So now it starts to move. And this printer is a self-adjusting printer, so it now it measures the height of the print bed in, I think, 9 different positions or so. It creates a 3D model of the print bed.
Yes.
And it does so in order to make sure that the distance between the nozzle and the print bed is exactly a specific distance.
Yeah.
So that it can calculate how much plastic it will press out through this tiny hole in order to produce the first layer. And the first layer is usually, the first layer is the most important layer because it has this adhesion.
Yeah.
And we also want to make sure that the underside looks nice, or the outer edges of the printed object looks nice.
So now it's curious to see what happens. This
Okay,
looks good.
so now it started to print, and it's printing an outer perimeter first. It has deposited some. Can we use that cam and move it around?
Yeah, probably. What happens if I click here?
And you're gonna remove it. Is it? It's one of the cameras below. Yeah.
Oh,
thanks.
cool.
Awesome. So let's see if I can move this one. Can we? Can we? Yes. Awesome. So now it's starting moving, and let's see if it. And it's depositing plastic on top of the hot surface. And we can see also on this little display over here that the temperature now for the print head is 230 degrees, so no touching. And it's starting with the first layer. So what Tobias do you say about the first layer here?
I think it actually looks quite nice.
Yeah.
I would be satisfied with that.
I think it's okay.
Uh-oh.
But we can see that it got a little bit unstuck in the outer edge here, so it drags along a little bit. So what can be done about that, Tobias?
I would probably say that we should clean the plate for this, but let's just wait and see what happens. Maybe it's not that serious also.
So sometimes the problem will, fix itself.
Yeah.
But we got a little bit of...
But I think just let it.
Leave it be. Okay.
You often fiddle too much.
Yeah.
But we will see what happens when it goes on the next layer. Then we can maybe decide if we should abort this and try again.
So I would say during the start of a print, you want to monitor your printer.
Yep.
You want to look at the first layer and make sure that it's a good layer. And, you should always, have some way of monitoring your printer so that you can go and I usually go and check it out every hour or something.
Yeah, definitely.
And every hour, this means that, these prints can take time.
Ooh,
so
coffee service.
Awesome. A big print, like, could we look at that print up there?
Let's.
Can we look at the big, really big print?
This is the largest one we have made.
Oh my God, it's eating me.
Yeah, but this is also then, it won't fit, right? You won't be able to print this. So this one is actually in parts.
Oh, nice.
So we print it in parts, and it has actually broken off a finger also. A little bit sad, but that's what happens.
Okay, so how big can we print on these printers?
It's a little bit different, of course. The surface area, if I remember correctly, what is it on the process, like 25 or 20?
Yeah, on the big one.
Yeah, on the big one.
25 times 25 times 20 or something?
Yeah, something like that.
And then on the smaller one, it's of course smaller, like I think 17 times 17.
Yeah, something like this.
But almost the same height. So how long did it take to print the big alien model?
That took several days actually, especially combined. I remember one of these arms required several prints because it was really tricky to print also. So yeah, sometimes it can take several days.
Yeah, and this depends on a lot of different factors. How big the nozzle you have. So if you have a big nozzle, you can output a lot of plastic at the same time. It also depends on how clean you want the surface of the model to be. So we have some examples of really rough prints here. I'm not sure that it's going to show up, but we can see the print layers of this one. And it's printed with this big nozzle, and it will take less time because you can output more plastic at the same time. This model that I put here is going to deposit with this small nozzle, 0.4 millimeter. It's going to deposit layers that are 0.2 millimeters high.
Oh,
and it's going to work for 10 hours. You have a good example over there? Yeah, as a counter example of how nice the print can be, Tobias is bringing in some handy print.
Spare hands.
So these
This
are
actually,
quite nice.
yeah, looks really,
I
really
can
good.
still see layers
Yeah.
of this. But this filament itself also has a little bit color difference. So it looks like marble almost.
Yeah. Cool.
Nice. But I mean, some of the surfaces, and depending on the settings, can be quite smooth. Also depending on the.
And
how
sometimes
good
you
it
get prints like this.
Oh yeah. So this is not really a print that you want, right? This is what happens if you have a bad surface layer adhesion, for instance, and the plastic tries to squeeze out through the nozzle, and then it adheses to the nozzle.
Oh,
and connects
you have
to the
more.
nozzle.
Interesting.
Awesome.
Cool.
So we have more cool prints here.
More
hands.
More spare hands.
So in this case, the plastic grew around the print head.
Yes.
And it formed a big ball, and this can actually destroy the
that's
finer
not good.
electronics on the printhead, because on the printhead on the hot end you have a heater, and you have cables going into that heater, and then you also have a thermometer or thermistor that measures the temperature of this, so the robot can know how long it would take. So
I think this is
quite
a
nice.
very nice print, actually. A cool design, and yeah, very good print, I would say. Often you can spot roughness in kind of like top areas, and you can probably hear now my finger drags along. And that's of course because the angle becomes so shallow, so that these layers are kind of like quite large in between them.
Yeah. So we have mentioned different kinds of plastics,
Yes.
right? But we have not really talked about them.
Yeah.
So this first plastic, this filament is a PLA plastic, polylactic acid.
Wow.
And this one is transparent, but it comes in every color. I mean, almost every print we have had here are in different colors.
This is another type of PLA, and it prints and it becomes a little bit glossy.
Yeah, nice.
So PLA has a really good variety of kind of like surface finishes and colors, and you put stuff in it so it glitters or shimmers and things like that.
It's a very easy plastic to start with also. So
and cheap.
Yeah, and cheap. So one of these, how much do they cost now? Was it really long time ago? I bought them.
€20 maybe.
Okay, for one.
Yeah, for one roll,
And
for one kilo.
Okay,
but
and you get a kilo of plastic.
you can find cheaper and you can find more expensive, but around that price, I would say.
So PLA is also very hard.
Yep.
So it's structurally hard. So you can, I printed stuff that I wanted to have a higher share. So I printed stuff in order to increase the height of my shares. So a piece of the legs for it. However, while it's hard, so it can take a lot of pressure, it also is quite brittle.
Yes, and that's typical for like breaking things like this. It kind of like just snaps off cleanly.
Yeah. And the way that that printing is working is that it's a layer. It puts layers on top layers of layers. So a print is always more vulnerable to break up the layers from each other, right? So if you want to have something that has, strength, you want to make sure that you have strength against the layers, so to speak.
And looking at this kind of like laptop stand, it's printed like this. So the layer lines are going like this, but the forces, it's
going to move in the other direction.
So it's actually quite sturdy. And this is also printed in another type of filament. This is not PLA.
Could you please stand on it?
Well,
is that okay? Would that be okay?
I'm not actually sure, but
So
we
when
can
PLA
try.
breaks, it sort of snap
Snaps,
break,
but
right?
this is like flexible, like mostly like normal plastic that you have in everyday life.
So if you print it too thin and you have movement on it, it easily breaks.
Yeah.
And then we have PETG.
And this is PETG.
Oh, and this is
Yes.
PETG. Okay, that is why it was so
Yeah.
flexible. Okay, so you don't want to stand on that. The white filament behind me here is called PETG, and that stands for, Tobias?
I have no idea.
Me neither. The other plastic.
Something else.
It's on Wikipedia.
Yeah.
Check it out. Okay, PETG needs a higher temperature to print. It also requires a higher temperature on the print bed.
It's a little bit trickier to print in general.
It is, and we did see that on the first layer that it failed to get a good adhesion, and it sort of dragged out like.
It's very flexible, like
it is
longer, like plastic fibers.
Yeah.
I think I would.
So
say.
you if the print head is depositing plastic and then it's gonna stop deposit plastic and then it's gonna start again, you sometimes get these small thin lines between. And this is one of the things that is also really good with PETG, that it doesn't break easily. So it is a bit more flexible. It can withstand or go back to a position. So you bend it and then it goes back to the other positions. Can we say anything more about PETG? Since it's printed warmer, it also can handle warmer temperatures. So one of the problems with the first plastic, the PLA, polylactic acid, because I knew it. Maybe it's wrong. One of the problems with the PLA is that if you print something for your car, for instance, and then the car is out in the sun, it becomes more than like 90 degrees in the car or 80 degrees. It will start melting again, so it will deform. So PLA can withstand higher temperatures for this.
PETG can.
PETG can withstand higher temperatures.
Yeah.
We also have some cool filament here.
Yes, this is a TPU, and this is a very flexible filament, and you kind of can even see it on the filament itself, maybe. And if I pull it, it's kind of like stretches. And
Nice.
I can break it also.
Okay. So with this plastic, it's almost like printing rubber.
Yeah, it is a form of rubber, I would say. And you can print really, if you can like need to withstand really rough environments and maybe take up really kind of like shock forces and stuff like that, you can use TPU. But this is then also 1 or 2 degrees more trickier to print because it's really, really sticky.
Yeah.
So you easily end up with these kind of like blobs that we had. Where did it go?
Yeah.
So it easily ends up sticking around your printhead like this instead of being a nice print. Then we have some really special types of filament.
This one?
Yes. This is a nylon with carbon fiber inside of it. Really expensive. I think this one is like 200 euros or something.
Okay.
This roll.
Okay.
Yeah, I would say that it's really for special applications, and also quite tricky to print, quite tricky to store. This attracts humidity.
Yeah, so
you need to
you
dry
have it
it
in one of these boxes. And in this box is heating up when you're printing.
Yeah.
So it sort of removes the water from the filament before you.
Yeah. And you probably want to run that like for an hour or two before you start printing even. So it's really attracts all of the moist.
Okay.
Cool.
So that was plastics. There are other kinds of plastic. There are a lot of different kinds of plastics. So one
ABS, for example.
ABS is one of these plastics that was very common in the beginning. But ABS is one example of a plastic that you don't want to print in at home like this, right? Because it produces toxic fumes. And there is also talk about these other kinds of plastics that we're standing close to, that it creates these microplastics in the air.
Nanoparticles.
That we breathe in. But fortunately, we're going to move from this place now and into my office. And we're going to start drawing for a 3D print.
Cool. Make something.
Yeah.
See you. Yeah, glue stick can be used. I don't think it's really needed anymore. I think the heating surfaces have become so good. Difference are more or less smooth. Yes, layer height is good for adjusting this smoothness or not, but you will always get a little bit, and you compromise with the time. So lower layer height is, yeah, you can like double the time you need to print. And we have a nice polyethylene something. Cool.
Okay, so let's see if you can hear me now that I'm in the office. And I've pulled up a program called Fusion 360. And this is a program for drawing 3D models. So just as an example, we could bring up a 3D model that I pre-drawn. And this is my design and not Tobias' design but for the same problem. So this is a stand for a laptop because I needed another angle for my laptop in my office because my laptop doesn't want to open up as much as the other ones. So Fusion 360 is, I think it's still free for students and for home use. So you can download it and you can register up as a student. And then you can use it for free. And I, as an educator, can also use it for free, which is nice. Okay, so this is, a 3D editor. And if you have drawn things in 3D before, then it's quite easy to learn this one. There are really, really good tutorials, but this is not the it's not the tool that you learn, just in one day, but you can follow a tutorial and get quite far compared to other tools like Tinkercad, which you can get directly started with. This is a one level up in complexity. So today I'm gonna do a very simple drawing of a 3D printed case for some electronics. And I'm not gonna, bother on trying to make it, really, really nice. I'm just gonna try to give you the basics of it. So one tool that I think is really useful when you are working with, so let's see if I can get myself here, can I? Who is controlling the feed? Can you put me in? Thank you. So one tool that is really useful for this is these measurement devices. So I can measure the distance. So if I have some kind of electronics, let's bring up some kind of electronics like a sensor. In this case, one of these small, I can measure its size and get accurate measurements. So getting one of these, or at least having a ruler to measure, is quite important, so that when you're drawing. We're not going to worry too much about that today. Instead, we're going to just invent measurements. Okay, so this first mode that I've done, is that I'm creating a blueprint drawing. And I do that in 2 dimensions. So this is a drawing board. So let's imagine that you're drawing a case for a Raspberry Pi or something like that. And I just use the rectangle tool in order to draw that one. And then I input the measurements of that I have decided on, for instance, 100 millimeters on one end and 70 millimeters on the other end or so. And now I have a top-down view of the lowest layer of that board. So let's finish that sketch off. And now I can watch that drawing in 3D. But in order to get something that is 3D, we can press pull. You press Q and you can press pull. There's also these commands up here. This one is called extrude that I'm using right now. and you can, drag out volumes into space. So let's imagine that I want to have a 2 millimeter thick. That is quite thick, actually. Maybe just 1 millimeter is enough. And now I got a 3D model that could be printed, a very simple one. I usually go layer by layer by layer from like the bottom to the top of it. So that is what we're going to do. Now we're going to, create a place for the electronics to live in, and we're going to raise walls around that place. I'm creating a new drawing on top of the topmost layer of the rectangle, or the 3D object. And now I can create the inner rectangle. So I created another rectangle over here. So since I just drew it out in space and just by hand, this new rectangle is not going to be exact. So in order to get more exact measurement, I have a tool called dimensions. So I can say that I want to have a distance between the outer wall and the inner wall. Let's create a quite big one. And I can say, I want to have 3 millimeters over here. And I can specify these dimensions. And I can make, one wall as thick as another one. So let's say that I want every wall to be 3 millimeters. So I'm going to measure the distance between these two. And I can say, instead of writing 3 millimeters again, I can just press on the other measurement and then get the same distance over there. So I do this for every wall now. I use 3 millimeters for every wall. Over here, and just 3 millimeters. So this is quite thick. So a 3 millimeter wall could withstand some pressure. If you have something that moves a little bit, you might want to have a bit thicker wall. If you want to use less material, you of course want to have thinner walls. So now that every wall is derived on the first measurement, I can change that measurement. So let's change that into 1 millimeter instead, to use less material. I can look at this drawing in 3D also, but it's usually best to just look from the top. So up here, we have a small cube where we can change the direction. So I got a question on how I inputted the measurement. So when I want to measure something, I press D, and I get this dimension tool. So if I want to measure or set the length of the drawing, I can use that one. Okay, now I'm going to use the same tool as before. So I'm going to finish this sketch, and I'm going to drag the walls out. And this was the extrude tool, and I just marked the outer walls. I could, extrude the middle area, but we want it to be. And I can drag and extrude. And let's say, a Raspberry Pi is perhaps 12 millimeters high or something like that. Of course, I'm going to measure it with my tool. So I drag out 15 millimeters and I stop there. Yes. Okay, so now we got a box, and this box can be printed. And of course, we could do, or we might want to do other things, like the Raspberry Pi easily gets overheated. So maybe we want to make sure that we have some holes in it for airflow, or holes in it for cables and stuff like that. So in this, no, let's do it in this end. I can draw on the one of the ends instead. And in order to get the outer walls of that, you can see that I have the outer walls, and I can draw the things, perhaps a port for the USBs or something like that. And then, as before, I press D in order to input the dimensions. Let's say that we have 1 millimeter from the edge, 5 millimeters to the inner floor. So you can see that I can see the inner floor through this, and maybe it should be let's output. Hang on, D again, and it perhaps should be 20 millimeters wide. And so you can see that some of the lines are blue and some others are black. So the black lines are fixed; they cannot be moved, while the blue lines are they can still be moved. So you can see, since I have not decided the distance to the edge, I can still move this back and forth, but the constraints that I've already put on it stays the same. So it's always 1 millimeter from the top edge. So let's say that I want it to be a couple of millimeters from this side. Of course, you measure this on your, the device that you're going to put in it. So now I have a drawing, and this drawing is on the side of this one. And I can press pull again or extrude, but this time I actually don't want to add material. If I'm dragging to this direction, I'm adding material. But if I'm dragging in the other direction, it understands that we have material and it tries to cut that material away. So there are different kinds of extrude operations that you can do. So you can have cut. The join was the one that you add material, and then we want to have a cut instead. And it seems unnecessary to, drag this out very far because the outer wall is so close. So I can say that I want to, instead of extruding a specific distance, I want to extrude to an object, and I just mark the side that I want to extrude to, and it stops the extrusion or the cutaway exactly on that side. So now we have a box with a hole in it. And I think one of the things that is also important for creating one of these cases is that these electronics usually have mounting holes in them. So I'm going to take one of these. So I have a sensor, and this one has a small mounting hole in it. So of course, I'm going to use my tool in order to measure the whole size of the hole. And I can see that it's 4 millimeters wide. And of course, I might want to, make sure that I know the measurements on where this hole is compared to the other things. And then I want to create some way of placing my electronics within my box. So when I decide on the position of that, I can, draw out this. And the way that I try to do it is that I create these sort of stands for where the mounting holes are going to be. So what buttons were used for deleting the extruded part? So when I extruded something, so I'm going to do it like this. Finish sketch. When I extruded something and I wanted it to cut away, I selected it's outside of the, hang on a sec. Maybe, not sure, maybe I need to screen share again for that to come in. I'm going to stop screen sharing and present and share screen again. Window, and we have this one. What's outside? Why is it? Okay, maybe I can drag. Oh, I cannot share it like that. It's not visible in the sharing.
Any overlay in an application won't be visible, so you'll have to share the whole screen.
Okay, so I have a small overlay here, and there is a cut fin on it. And I think sharing the whole screen is not a good idea because I have a very big screen. So imagine an overlay. Imagine a button on the overlay that says cut. Okay. So now I go back to, I created a new drawing on the inside, on the bottom floor of this one. And I wanted to create something to attach my, my board to. So in this case, I'm going to create some kind of pillars. And And I'm just gonna input the dimension, and as everything else, you can press D in order to input the dimension, and then I say, okay, maybe if it's a 4 millimeter hole, maybe I need to have 6 millimeters of pillar in order to have that. And of course, I decide how far from the edges this thing is going to be. And as long as I have not decided it, I can move around the hole freely. But I try to make sure that I lock in the positions of everything. So maybe this one is going to be 15 millimeters from the top edge and like 15 millimeters from the other edge. And now you can see it turned black. So I finished the sketch, and now I can press pull out of that one. And maybe a couple of millimeters, like 5 millimeters, is enough. So it's going to be 5 millimeters from the bottom. And now on the top area of that one, I create a new drawing, and I just want to have a hole here, and it should be 4 millimeters wide. So I could press pull and cut away stuff from that. But then I would get a circular hole, and a circular hole is not really good for putting a screw into it. You could, heat up the screw and still drive a heated screw into the plastic, and that way creating these threads for it. So another way of doing this is to use a hole tool in Fusion 360, and maybe I can, fix so that you can see if I share the whole screen on my small laptop screen. Let's try that out. And then let's move this one here. Share screen, entire screen, and screen 2. Yeah, okay. So now we have that one. So when I bring up the hole tool, I can select a tapped hole, and that means that you have it creates a 3D model for the screw threads, so that you can drive down a screw into it. And I select the hole, the position of that one. I can decide how deep it should go. So we want to have 2 millimeters. I think that 4 millimeters is a good distance. Yeah, something like that. Oh, it became very, very small. So now I have a really, really small hole here. Let's see if I can show you. And I want to make that hole bigger. So one of the advantages of Fusion 360 is that every operation you do ends up down here. So here we can see history of everything I have done, and I can change the parameters of that one. So I'm going to select an 4 millimeter instead, and I want to have an M4 screw, and this is a machine screw. So the M4 is a 4 millimeter wide machine screw. And now we have a hole that can be 3D printed, and you can mount your board on top of that one. Yes. So I think one of the nicer things with Fusion 360 is that if you've done one of these and you want to have more in a specific pattern, like you want to have rectangular pattern of holes, you can do things like creating a rectangular pattern, and you can select what kind of objects. I'm going to use features, and I'm going to this one, and I think I can select the other one also, perhaps. I'm not sure. Can't I select this one? Yes. 1, 2 features.
That's not that one. Then I can select an axis, and I can say that I want to have 2 of these in this axis, and I want to have 2 of these in the other axis, and I can set, you know, the dimensions of these. So now I have 4 different screw holes, and I can create this. You know, you design something once, and then you just copy it through this tool. And if I want to, you know, change how many of these, I can change everything here. So let's imagine that I print one of these, and I find out that I did something wrong, which is usually the case. We jokingly say print and toss, which means that you print your case and you realize that it's something wrong with it, and then you need to print it again. Yeah, and then you want to go back. So I can go back in time, and I have this tool. So now I have stepped back a couple of steps in time. So you can see that this was before I added the mounts for the one, and I can go back all the way to the beginning, and then I can step back, so I can edit everything. So let's imagine that I want to have a thicker base for it. Suddenly, I just changed that feature, and now my design has a thicker base. I think this is more or less all I want to show you in Fusion 360, except creating or, you know, showing you how to output this into a 3D printer. So let's do that thing. In order to do that, I need to save my design. Let's call it case. And then I'm going to output a 3D model from Fusion 360. And this is called save as mesh. So I'm going to output a mesh. And I want to, there are different formats for meshes. And the 3D printer can take any of these formats. But the 3MF contains you know, a little bit more information than the other formats. So I think it's the STL or the OBG format that doesn't contain what kind of distances it is. So it doesn't contain the information that we are working with millimeters, for instance. It's, you know, when you load it into the printing software, it might ask you, is this millimeter, or is it meter, or is it yards, or, you know, any of these. Here you can decide how refined your mesh is, and this could be quite important because we had this really small threads. So we can say that, oh, I want to have this highly refined, which means a bigger file, essentially, that it's going to take a longer time to load. Medium quality is usually enough, because now it moves from how it represents objects in Fusion 360, where it has, you know, these really smooth edges, so it can be perfectly round in Fusion 360, but we're going to create a mesh from it, which means that we're going to create a triangle mesh, and triangles are not perfectly sphered, for instance, so the outer edges of these mounts is going to be, you know, could still look smooth, but it's still constructed by triangles. So, and then I just say that I'm going to put this on my desktop. Now I have a file on my desktop, and we're going to start up Bamboo Studio. And Bamboo Studio is a tool for taking a 3D model from Fusion 360 and create or decide how it's going to be printed. So a 3D model then is this mesh thing, and I'm going to input my model into this one, and let's see if we can find it. It was on the desktop. I called it just box, didn't it? Case, perhaps. So let's see if this one was the one, and I'm going to ask it to arrange things. Let's see, is this actually the one? Yeah, it looks like that one.
And oh, why is it so black? Can't I change? It's because it's gonna be printed in black plastic. In order to decide which material I'm gonna have, I need to understand what kind of materials I have in the printer. So I think that maybe going back to the IT lab and look at the printer would be a good idea in order to know what kind of material we're gonna have there. Yeah. So, okay, let's do that. And I'm gonna mute myself here. And
Let's see if we have Tobias here also. So what kind of materials do we have in this printer? So can we see?
You could maybe take this camera.
Yeah, I think that one's. So this is the bamboo printer.
Yes.
It's the newest edition of printers that we have here. And it's a multi-material printer. So we have...
I think this is PTG and two PLAs.
Yes, so we look at the roll and we can see, okay, PTG.
I think this is a PTG also, not sure.
PLA.
PLA.
So the white one was a PLA.
And this is a two-color filament, it's PLA.
Yeah.
And if you look at it from one angle, it's green, and from the other, it's blue. Pretty interesting. And this is a PLA with some glitter inlays into it, and it actually is this one.
Yeah, nice. So if I'm gonna print with that one,
yes.
So it was PLA, right?
Yes, PLA.
Okay. So I need to select PLA settings in Bamboo Studio in order to, but maybe when we're here, we can, look at the insides of this print because it looks a bit different.
Yeah.
It is a box.
It's definitely a box.
And
this should be cleaned.
Yeah, so let's do that first. So which side am I going to use?
You will use the other side.
The other side?
Yeah.
Let's clean the other side also.
This is the engineering plate.
Okay.
And this is the PLA PHG EBS. Cool plate side.
So the reason that we clean this is that I'm going to leave fingerprints on this one with fat, right? So a lot of alcohol. And my fingerprints or the fat in them is going to be maybe creating less surface adhesion.
I think we actually had some.
Did we have? Yeah, can remove that one also. Then I'm gonna put it back inside.
But as you can see, the anatomy of this printer is a little bit different. It would be very strange for this bed to move back and forth because, if we close, it cannot move. So instead, actually, the bed in this case moves up and down. You can see that because we have these lead screws that can control the height of the bed. And instead, the print head moves in
2 dimensions.
Yeah, in 2 dimensions,
Back and forth.
left and right, and back and forth. Cool.
Okay. Okay, so now we have the PLA PHG ABS side up, and we've cleaned it up. And we can go back to my office. And I think, Tobias, I want you to join me because you are more an expert of Bamboo Studio.
Expert.
Yeah.
Expert.
Daniel, you were muted, so if you intend to speak to the audience.
Yeah, we intend to speak to the audience. I thought
Yeah.
you could read my lips. Should that be, the basic skills of a distance student to read the professor's lips? I think that is a good idea. Okay, so what we've done is that we've changed the plastic, and Tobias showed me how to do it because I felt nervous and forgot about how to do it.
It's a little bit tricky, actually.
So now I've changed the plastic to the PLA plastic of the fourth container in the printer. And now, and maybe I could say something more that, we talked about different strengths from different sides. So the placement of the objects inside the printer is also important that you get it right. And now I've constructed my print in such a way that it should print from bottom to top. But it could be that the object is, shouldn't this one auto place? Can I need to select it? I guess you want that one. Leg point. Yes, this one. So for instance, if I wanted to print it on the side for, strengthening it, I can, decide which side I want it to print with. And I think this one is, it has an auto placement tool that is quite nice. But there are some things to think about here, because a 3D printer is a head that is outputting plastic. It's almost like, you're having your toothpaste, your tube of toothpaste. And imagine that if you have a print surface, you can output toothpaste on that print surface, or caviar on your sandwich, right? But if you have, if I place this top down and it's going to start printing the mounts for the board, it cannot do that in thin air. The toothpaste will fall down, right? Yep. So we need to make sure that we have.
You could just try
support.
it and see what happens.
Yeah.
Wow, your mouse is really slow.
Yeah, slow mouse guy, call me.
So let's do that. First, it kind of like warns you a little bit that this does not seem correct. So but if we scroll down to the layers, we will see that, all right, we have come up like a centimeter or something like that. And these little dots that appear soon, they will be hanging in midair. And that won't work because it's not magic. So this will fail, this print.
Yeah.
If we print it like this, it won't work.
It's going to be toothpaste on the billboard. Okay, so we can go back to prepare. And decide that we're going to print with that in. Okay, so Tobias is pressing beredplattan, which means arrange or prepare.
I think it's called slice.
Yes.
Or something like that.
So this tool that we're looking into is more generally called a slicer. It takes a 3D model and it slices it up into really, really thin layers. So you can see Tobias is moving through the layers, and each of these layers is sort of instructions for the robot on how to move and how to output plastic for that specific layer.
Yeah, and we can see that every kind of like layer has support from a layer below it.
Yeah, that's super important. Yeah.
All the way until we come to, let's see, this part.
Yeah.
Because this does not have support from the layers beneath it.
Mm-hmm.
However, well, we can see that it can kind of like, if we can attach things on both ends, this could actually be a working print. So this is called a bridge. So with one strand of plastic, we could go all the way here and attach it on that side. So this could actually work. The plastic is melting, so chances are it will kind of like drop down a little bit. But we also have cooling fans on the print head, so they will try to cool this as soon as it prints. They will try to cool it and make it as horizontal as possible. So I think this will actually work. And we can see also that this has a different status here. It's called bridge. So it's you can see that it's one layer of this, and then
Get normal layers on top of it.
So it will probably start the fan, and it will print with a certain speed. So it's probably a little bit faster, I would say. And it will try to cool it so it actually can print this part anyway.
Yeah. So if you have a plastic like PLA, these bridges can actually be quite far, right? So if you have a good printer and with a good cooling systems, I've seen bridges that are 10 centimeters. And of course they can sag down a little bit if you're unlucky, so to speak. But I think this one is not going to be a problem.
No, I think it's going to be quite good actually. And I also think that since we have a 0.4 millimeter nozzle on this printer, it's not that much plastic that comes out, and it will of course then be quicker to cool. If we have our 1 millimeter nozzle printer, there's a lot more plastic. So those layers, that plastic will be much warmer, much more mass, so it will not be able to cool it as fast. So those bridges are harder.
Yeah. So I want to show them also how to decide how fast it's gonna print and the layer heights.
All right.
So we can see. So I guess we're going back to prepare now.
Yes.
Eller förbered.
I think it's probably easiest to do this way, and we can just set different heights. So 0.2, we can set the number of walls that we want. And actually, we can also have support material. And this is for parts that maybe you have a model that however I orient this, there will be these parts that will not be able to print. So if we activate supports, and maybe we do this wonky thing again, we put it upside down and we prepare, and we will see what happens. Now it kind of like, it adds stuff. And it will probably add a lot of stuff on this inside.
So we can see it filled it up.
Filled it up to support all of these parts that are now kind of like not anymore hanging in midair, but we remember these little stuff here.
It tries to support the entire inside, right? Even if it could bridge some part of it. Yeah, so the supports are really good if you have a print that that has something hanging down, and you cannot find an orientation of the model to avoid it. So what happens if you prepare the plate now?
Now we are back to normal.
Oh, but you still have support activated. Click support activated. I think it's going to try to add some support material for the hole. In order to avoid that bridge. So I think we're going to keep it this way.
All right.
So could we have another filament for the support material, or what?
Yes, I think so. I've not tried it, but there is a possibility to.
Because it would be nice that we have a two.
Yeah. Okay. Cool. Let's see how we do it. I have not done that actually.
I see that we don't have time.
All right.
So maybe we just start to print some.
Yeah. I have not done
so
that.
The supports are going to be printed in such a way that they are going to be easier to break away. However, if you have a lot of supports and a 3D printer that is not very calibrated, it can be quite hard to break away the supports from the 3D model without destroying the model.
But here we can do it.
Okay.
You have to activate advanced. So
nice.
Which should we do?
Number two.
Number two.
Yeah. Because the first one was PETG.
Yes.
So we want to have just one material. Awesome.
Cool. Now it should be some other material.
Okay, we can see that we got a bit of structure on the side there. Well, what is that?
Well, since we only have one nozzle to push the plastic through, we want our box to be cleanly printed with one material and the support cleanly printed with another. There's always some residue left in the nozzle after switching the filament, and we need to kind of like print a little bit to get rid of that. So this is what this is called, the purge block, so that the material is kind of like clean when we start to print the actual print.
Okay. So I see that we got a question quite long ago, an hour ago almost, that I didn't see, but I learned to use a glue stick on the board before printing so it adheres properly.
Yeah, I actually answered that one when
Oh,
while we switched.
Awesome,
So,
good.
But I think
Good work.
sometimes it could be used, but I think often the plates nowadays are
so good.
So
Yeah.
it's not needed.
I very rarely use it. I use the glue stick if I fail a number of times.
Yeah.
Okay. So we can press print.
Yeah.
On this
Maybe
one?
we should. I always recommend you to take a look.
Yeah,
take a look
through
at
the
the
layers.
first layer. That's kind of like, if this looks okay, yeah, then you're probably good to go. If it looks wonky, then not so much. And you can, let's see, I think we have a little slider here. So you can actually take a look at exactly how the print head will move.
Yeah, because the slicer is creating instructions for the 3D printer, and the 3D printer is essentially a more or less dumb robot.
Yeah, you can.
So
see
it's just gonna follow these instructions. So these are, move print head to the right 100 millimeters, then move print head to the up 0.1 millimeter, move print head. Heat up plastic to this amount. So these instructions are called the G code.
Yeah.
And we can see the G code instructions here on the screen.
Yeah. G1 is probably move to this.
Move head 1, yeah.
And extrude this much plastic.
Yeah. So it has a speed, movement speed. It has how much it's going to move the extrusion of plastic and everything. Yeah.
Yeah. But I think this looks fine.
Okay. Press print. We go back to the.
All right. Let's go send.
So this printer is quite nice because it has a camera. So I think we can.
Maybe we can, in some way, hook up to that stream.
Yeah.
I believe we'll also shortly get an update from Hässö. It looks like they are.
Good. Take over Hässö. Hi, Hässö. You're muted. It's not just
classic.
It's not just.
Can't unmute it either for some reason.
Oh. Maybe they're not listening, and maybe they have a lot of. So could we make voices for Oksana?
David, I'm explaining this IoT sensor now. They're very, very advanced. It will send to the mobile phone.
So what is that? We're on a ship right now, right?
High quality voiceover right there.
So could we place them so that we can see more of them?
Oh, the print is soon done.
Oh,
my new laptop stand.
Okay, so awesome. Now we got some feed from the printer also.
I tried standing on it, and it actually worked very well. You're muted, guys. Oh no.
Can we ask them to unmute? I unmute them. Can we? No.
No, you can't. I'll write that.
To unmute.
Yeah, maybe we can just wait for him a little bit.
Yeah. Still have my screen shared. Maybe we can, we can see that in the inside of the printer. And we go to the printer now.
Maybe can we do it full screen or something like that?
I'm not sure.
But it's really laggy. This is actually one of the.
Yeah. So we are going to the printer now and continue. Now,
do we have something? Which camera? No, wrong camera.
We have some here. Am I muted?
You are not.
Am I muted? Can I bet?
Yep.
Awesome. Okay, so I think maybe we start looking at the screen.
Oop. Can we see something?
So we
no,
can see
it's
that
really glaring.
yeah, the screen is
Oh.
showing that it is heating up. So it's almost 200 degrees on the hot end. And it's 35 degrees on the build plate, I'm guessing. And we can see on the inside, open up, right?
Yeah.
And it started to preparing for a print. Starting to move the head, and it's doing a lot of different things. This printer, it's cleaning its print head. It is calibrating the distance to the board, just as we saw the Prusa printer was doing. But it also has some kind of scanner, right? So
it has a LiDAR.
A LiDAR. Okay, so this is a laser
radar.
Laser radar, and it can inspect the first layer, and it can stop the print if the first layer doesn't look right.
And it also calibrates the extrusion using a special pattern that we will see in the beginning.
So and that means that it decides on how much plastic it's going to output, I'm guessing.
Yep.
But this looks like it is still preparing.
And this printer is freaky fast, actually. So
yeah, it's doing a lot of funky stuff. That's the technical term.
Yep.
Well, David, I'm still on a ship. Oh, we got voiceover. So it's measuring the distance to the board in different positions and creating a 3D model of the board.
Yeah, I think it's 16 different positions on this one.
Okay. And now it's shaking.
Yeah.
Making a lot of noise.
Yeah, it's actually
Vibration.
calibrating itself for vibrational artifacts. So it knows how much and at what frequencies it can starts to self-resonate. And that's something you want to avoid.
Still doesn't output any plastic.
No, it will be a while, I think.
Yeah.
So now it starts, and it will print a special pattern, and then it will scan this pattern to calibrate the extrusion.
So compared to other printers, I think this printer has been, more or less press print and forget.
Yeah, more or less. We have had some clogging issues,
Okay.
but I think we have printed a lot, so I think it's actually time to switch the nozzle. So that's, yeah, things kind of like get wear and tear, of course, and I think that's, yeah, some one thing that you you cannot avoid. But otherwise, it's been really a good experience, I think.
With nozzles, I think there are two things that can happen. So if you have an abrasive filament, like the carbon filament, the filament itself contains these really sharp and hard things, like the carbon fiber.
Oh, now it's scanning it. This looks super cool.
Awesome. And the carbon fiber particles can, abrase the inside of the nozzle, so it becomes bigger. So you no longer have a 0.2 millimeter nozzle; you have a 0.25 millimeters or something like that. So you need to output more plastic and recalibrate the print from that. And the other way a nozzle can sort of fail is that if the plastic contains particles like dirt particles or something like that. So then these dirt particles can get burnt and stuck inside the nozzle. So you get a smaller nozzle. So it's no longer 0.4 millimeter. It's 0.39 millimeters or something like that.
Or even fully stopped.
Yeah. Okay. Now it's starting the real print. Looks like.
Yep.
First layer of that one. So the nice thing with having a box and having the printer is that a printer produces some noise also. So the noise will be reduced, and I know a lot of people who are building in their 3D printers in wardrobes and stuff like that. Do we know how long this print is going to take? If we go to the home screen, maybe.
3 hours and 23 minutes.
Okay. I mean, the first layer here looks awesome.
Yeah, will be interesting to take a look at. Was it the Raspberry Pi box?
Actually, I've never measured anything. I'm just
All right.
inputted some random numbers.
All right.
Because I wanted to illustrate things and not sit with a measurement device.
Yeah, this looks really good.
Yep. And maybe we can use the feed from my office. Or moving to the ship.
Yeah. Yes.
Okay.
See you.
Do we have sound on Hässö? That we do not. Looks like a very rainy trip, though.
I think you say something. Yeah, I cannot.
Hello.
You can hear us?
Yep.
Yeah, I think they can hear us. Yeah.
You can hear us.
Yeah. Joachim is giving us a thumbs up. So.
So you can hear us now. We can't hear you. Now you can speak.
Okay.
Yeah, we can hear you.
So where are we going?
We are going to a nature reserve and the destination Hässö, a little island in the Västervik archipelago.
Yeah.
We have been trying to get off the boat now a few times because we thought it's the right island, but
I think the next stop is where we're gonna go off. So.
yes.
How many people live here?
I think we just look it up. It's only 35, so it's literally like a micro settlement.
Society. Yeah. So, and we're here. Maybe we could say a few words about what we're doing here, why we're going
so
to
the
Hässö.
project. Yeah.
It's one of the projects that we have in the IoT lab, and what we do in the IoT lab is to work with small and medium-sized companies, and Hässö is one of them. So what we're gonna do here is, let's maybe start with what challenges they had. So they have, first of all, they have these ice cream fridges. So when people buy ice cream, oftentimes sometimes they forget to close them properly. So, and that obviously is not good. So they want a way to monitor these. So if a lid has been open for, let's say, more than 40 seconds, then probably it should be closed. And then an alarm should go off. So that's what we're gonna install on 2 of the freezers. And then we're also gonna install a bath temperature sensor under the bridge.
Can I have this? Probably this the other microphone.
So yeah, that's what we're gonna do, and we're gonna use LoraWAN, and in particular, so we have a helium gateway. You probably can show it later on, but we have a helium gateway with us that we're gonna start by installing that, and then we're gonna install the sensors. Yeah, I think it's working. So that's what we're doing.
Yeah.
Yeah. Anything else? Well, we'll update you. You can, as soon as we start the installation process, we'll.
Now we can stay on and just show what's happening, but probably won't say that much now for a little while.
Yep. Cool.
Hopefully, figure out this with microphones.
Yes, I think we just mute now. So.
Yeah, so now we have Fredrik with us as well. Hello, Fredrik.
Hey, how is everything?
Everything is good.
Great. So we thought that we perhaps should make a quick demo of a project that has been ongoing in the lab. We have a project that is called Smart Lashing. And in essence, this is a project where we want to connect, I would say, cargoes and have a sensor that is measuring if the cargo on ships is moving or not moving. So it's a lot of would say high value cargo that when you put lashes, that is in Swedish spännband or some kind of securing or fitting. And well, ships, they generally move when it's windy and there are waves and that stuff. And you don't want this cargo to well, move.
No.
That's generally it. So I'm here also with Andreas. Yes. And Andreas, you have been doing most parts of this together with David.
Yes.
So let's have a...
Should I maybe start my video?
I can
start the video, yes.
Let's see. Add to stage.
Let's see.
And let's see. Har vi dual?
Maybe you're both muted, so I don't know where the sound comes from.
Okay, maybe
no.
We have a mic here in the 3D printing studio, so maybe that's the mic. But I'm not sure. Everything is fine now? Or?
Yep.
Okay, great. So now we're picking up the microphone from my computer. And we do now have a video. I'm just going to play it, and you can sort of just guide us through this video.
Yes. So let's see. Can I take it from the beginning? Yeah. So we have a Heltec LoRa Wi-Fi 32 and a HX711 load cell amplifier and a VTech load cell. I don't know if they can see.
Let's see. I've had yet another camera.
Oh,
here.
yeah. Okay, nice.
If you put that up big.
Yeah.
Yeah. We don't need to see it, but the people here. So maybe you can.
Yeah. So we have a breadboard here, just a prototype at the moment. So we have the Heltec, which is a microcontroller, and the HX711 load cell amplifier that is connected to the actual load cell. We can see up here. So now we're just simulating like a cargo on the ship. So yeah.
So that box is supposed to be like some kind of cargo that is on a ship, and then we have Biltema. Yeah. And this device, like, is essentially what we see here.
Yeah.
Is it's not. I can't bring it closer because the wire is. We could do like this. I'll move my computer and we'll use. So if you add my screen, yeah.
So here is the actual load cell. That is like measuring the strain, or how to say, in the actual Biltema spännband. So if the slack, if the cargo or the spännband is breaking, then the strain will be less. So this load cell is connected directly to the HX711 load cell amplifier, which amplifies the signal from the load cell by a certain gain, like 32 times, 64, 128, and so on, depending on how the resolution would be. And this is then directly connected to the MCU, a Heltec, which is sending that data over LoraWAN. Yes.
Okay, so we more or less have that setup now explained, and you're now going to sort of we're going to demonstrate the video where this is set up.
Yeah.
Then we can go and talk through this. Okay.
Yes. Can I?
Just you don't need to make it bigger.
No. Okay, so we have a Linux VPS, which is running Ubuntu, and a Python script that is just receiving the data from SherpStack, which we're going to see later. And this HTTP server is taking the data and inserting it to an influx database, which we're also going to see later. So it basically receives the data to a byte array, unpacks it, makes it to a point, and then it just inserts it to the influx.
So you mentioned a couple of things here. If you pause this for a moment, so we have SherpStack and we have influx. Yes. So what are these things?
Influx is a time series database where you can store data over time. And SherpStack is what is SherpStack?
Yeah, that's a LoraWAN network server.
Yes,
and it's an open source network server that, well, you can install on a Raspberry Pi, and if you want to host your own LoraWAN server, that's the way to go.
Yes,
essentially, and it's open source. So Helium, for instance, actually, like a lot of these Helium servers are operating on SherpStack. So it's necessarily don't anything. SherpStack might be a software that you're using without knowing that you're actually using it. It could be, but essentially, the server that receives the LoraWAN package. So the gateway itself could just be forwarding the LoraWAN packages to the server, and the server could be on the internet. Or the LoraWAN server, like the SherpStack server, could also be on the same device. So it's different.
Yes.
But essentially, you could have a very, very stripped down version of a packet forwarder. Like it only receives the radio signal from the LoraWAN devices and forwards that to the LoraWAN server. If you are, for instance, using the Things network, that is what you're doing. Then the Things network is the LoraWAN server. That's the server that receives the signal and also decrypts the signal, because you have these keys that you need to exchange, that it's on the device and needs to be authenticated and so on.
Yes. So so after we have received the packages, now we are starting up the script, so it will be run in the background, and all the output to the trash can. See, now we can see the server is running and ready to receive the packages from the SherpStack integration. We can. I would like to.
I'm not sure if that's
no, it's not possible. So now we are running now we have started the software on the Heltec device. It's running MicroPython at the moment, and now we have started the software, and we can see it's trying to join, and it has joined and is reading the values from the HX711. And when enough values have been read, it's sending them over the LoraWAN.
So these values are sort of the tension now.
This is the tension. It's not representing anything. It doesn't have a unit or such. We're only interested in the deviation from the strain that was there from the beginning. Because if this value was dropping, then the tension has gone down. And now we can see we're entering the influx database to see the values we have received.
And influx, by the way, it's actually also a quite nice visualization tool. So this has been like if you install influx DB, you can install that also on your computer. You don't actually need a server. You
No,
can
no.
install it just with a Docker command on your laptop.
Yeah.
And receive data, but you can also visualize data in InfluxDB. So what you see here now is the Explorer, Data Explorer. So, and from that, you are able to also create dashboards and put a lot of different data types on the same dashboard and so on.
Yes.
So you don't necessarily need Grafana.
No, we don't need Grafana, just if you want to make more nice queries and such. But you can use Influx for visualization also. Yes. It's quite funny because if you look at the screen here, you can see we installed this on a boat over here, Kalmar Nyckel.
Yeah.
Yeah, and we can see that the load cells are actually temperature sensitive. So the material in the load cells are expanding and contracting. So the tension in the band actually goes up and down. So that's a problem, actually. So it will be addressed in the future. Yeah. So that's why the graphs are going up and down, as you can see. Now we can see the actual Python code that is being run on the device.
And now you're using MicroPython for the HealthTech device.
Yes, yeah, for the HealthTech device, yes.
So why did you what was the basis of the choice of using MicroPython?
Yeah, it was just like quick prototyping.
Yeah.
Actually, right now it's running ESP-IDF because I'm taking it one step further. To really get a small binary with a small footprint and better power consumption and such, deep sleep modes. So just for the sake of prototyping, MicroPython is quick and easy.
Yeah.
Yes. So it's quite basic. It just sets up the pins for input output, and while true loop reads the values from the HX711. Packs it down, shows it on OLED, and then it sends it away, a byte array. You can see here. Yes, so that's basically what it does.
Yeah.
Pretty easy. This is just for visualizing the output right now to test the different values and see the deviations on the graph. So next step is to have like an alarm system, so we can get like notifications when this load, maybe the strain in the span band is going down. Yes.
So at the moment we are not like following any questions and so on Discord because we are using the computer for. So if there is anything you need to sort of shout out, Joachim.
Yes. So now
I got it covered.
Okay.
Great.
Yes. So now we are in the Chirp stack. We've entered the application. It's a tenant LNU IoT. And into the device. So here we can see an overview of the device and the configuration for the device UI, join UI, and such, and the OTA keys. And we can see the actual frames being sent and received from the device over LoraWAN to the Chirp stack. And in a moment, we can see the payload here being received. So here we can see the byte array coming in and the object tension here as 4 different bytes for the tension value. I would like to
So
yes, and now we can see the integration. When we first started the video, we can see this Python server on the VPS and the HTTP server we were started. So here from Chirpstack, we are making an integration to that server. So you just send a post request with JSON data in it. That's the actual byte array containing the tension to that server. And Chirpstack also has an InfluxDB integration directly. We tried to use it, we tried to read the docs, but we couldn't get it to work. So that's why we resorted to the HTTP variant instead. Yes, and here we can see when I'm building the breadboard with the different components. So here I'm placing the Heltec device on there and my little antenna holder I made from a wire. And the HX711 load cell amplifier. Actually, a bit forward. Then just a matter of connecting the wires. So this is just the prototype, basically. So in a future version, like I mentioned, ESP IDF for a smaller footprint, we would actually might not use a Heltec device. May we break out the SX LoraWAN chip and the load cell amplifier chip to a much smaller breadboard. We make a tiny device out of it. So just connect the wires. I think I actually reversed ground and
you did some mistakes when you
yeah, I did some mistakes, yes. I actually did. So we all make mistakes. Let's see. Yeah, now we can see we have the tension value here. Also just for demo purpose and prototype purpose. Yes.
Great. So we can remove the video, and we see now that they are up and running with a lot of things in Hässö, I believe. So I could just wrap that this project up. I see that my video isn't the best, but you can see my but I have some backlight from the windows here. But in general, this is a project that we have been doing together with RISE and Lighthouse, and this is one project I would say that a lot of ideas come from okay, are we able to put IoT sensors on this thingy? And there might be a problem that, okay, we have this high value cargo. And what we do in the lab is often that we prototype things and we sort of, okay, we have this sensor, are we able to connect it and catch the data? Are we able to send it? And you won't get I would say a product out of this from the beginning, but I mean in the beginning it's all about prototyping, doing a lot of trials and see how does it actually make sense. And for one thing is for ships, you generally have very poor Wi-Fi connectivity. You generally have like if you're going to use Bluetooth or whatever kind of other physical protocol, LoraWAN is actually quite a good fit. You would need a local server because you might want to keep the data on board, like on the ship. You might not want to be dependent on on the cloud. So Chirp Stack makes total sense. And in this case, it's more or less what we built. So you're able to do this with like quite small effort, like at least from the prototype level. So we'll see if we can. You're saying goodbye now, Daniel. Yeah, okay. See you.
See you.
Yeah.
Yes.
Yeah. So I'm not sure if they want to pitch in something from Hässö or if they like. I think we've we are at 12 o'clock now. So if they want to, going to mute my.
Ja, vi lite olika aktiviteter. Förra året var vi med Destiny. Visade vad vi hade kopplat upp.
David, I think we are on.
Yes, okay, so do we know that this is working? Can you...
I think so.
Can you
It
confirm
seems-
if it works?
Yeah, just a thumbs up or something, and you probably can see.
No, you need. I think that they are not using the right microphone. So the microphone is not connected to the iPhone. They're using the iPhone. They're picking up the iPhone microphone.
Okay, but let's try with the other. Did we try with the other cable?
Yeah, we tried with other cable, I think, in phone issue.
You should be able to get it right now from the phone. So we
Yeah,
disconnected the
we can hear
Yeah,
you
but
from
I
the
think
phone.
I'm
That's
close
very loud
enough
and clear.
to just describe. I think they can hear me quite well now, I guess.
Yeah.
Yeah, so we're now at Hässö, and what we're going to start by installing this gateway. So what you see here is an outdoor LoraWAN gateway. This is at the moment configured to forward all the packets that it receives to the Helium network. So this is what we're thinking of using here. Once this is set up, we do have a couple of sensors. I think I mentioned it briefly just a moment ago, but we have a Dragino sensor. This is to measure the temperature in the water. So people that want to take a bath or like a swim, not a bath, to know the temperature in the water. So this is one of the sensors that we're going to onboard, and then we have the a magnet sensor. This is.
Where did you throw away the microphone? Sorry.
Oh, the microphone is here.
Yeah, because I can.
Yeah.
I can still...
So we have a magnet sensor here, and this is to determine if the freezer lid is opened or closed. So if it's been open for, let's say, more than, for example, 30 seconds, then it should send an alarm, or you can set that threshold to basically anything. So 2 of those and a temperature sensor.
Can you also describe how far are the sensors from each other or from the gateway?
From the gateway, I think, like distance-wise, if we have the gateway here at the motel, down to the beach is probably like 500 meters.
Roughly.
Roughly 500 meters. But we're gonna, like the map that Lennart prepared here is, this indicates where the gateway will be placed, and then these red dots are the points of interest. So here we want LoraWAN coverage because maybe in the future we're going to be installing sensors here. So this is what we're going to be what we're going to do today. As soon as we install the gateway, we're going to go to these places and then try to map.
How far are they from the...
I just Googled the distance.
3,000 meters.
Yeah, around 3-4 kilometers between. Yeah, these
The
two
furthest,
points. Yeah. So this is what we're gonna test today. But now, yeah, let's maybe install the gateway. We said that we would lead the cables to the other side. Yes, the both power supply cable and the Ethernet cable. Yeah. This is surprisingly light. I don't know. I think compared to this one, it's like really light. Yeah. Take this, and then maybe these we take last. And did this work?
Yeah, it worked too. I was filming as well for the. But I'll try it now on the different phone.
Yeah. So.
put so you can see. Here's a good spot. Wait.
Ja, hade vi... så vi kunde skruva dem här, eller? Jag tror du hämtade någonstans ifrån här i närheten. Verktyg för något.
De nog bara med fingerkraft.
Jaha, okej. Ja, ja. Men då ska vi köra upp det. Finger power. Det här var gå upp, va?
Jag kan ta skruvarna,
Ja.
annars slipper hålla dem. Så kan jag ta dem. You want to bring that one or first install this one?
No, we're gonna install that one, and then if it doesn't work, and that we can try with the other one. Other stuff. Det är bara att gå upp.
Har du telefon?
All right, we're going up to install
Yeah.
the gateway now.
Oh, you're yeah.
Yeah.
So that's what we're gonna do. First, I think one of us should go the other side. Yeah, I'm just gonna, I think, climb up
Without
any
safety. Don't repeat it.
I think better from this side. Yeah, I'm gonna go with that. So I'm just, don't do this at home. I'm just gonna try with see Lana.
It has a really nice view here.
Yeah.
It's good if you will stay overnight. It's amazing here.
I can see myself there too. it's big. All right.
Oh, we're waiting for screwdriver.
I just put it
Yeah,
here.
it's wet.
Yeah, it's wet.
But anyway, these are also working.
It's like a slow TV here now.
Yeah, maybe we can have. Yeah, exactly. We can if we have the phone there.
I think one of us should go the other side and then take one by one.
Yeah. We'll do that. But the thing is, I just need to talk to Lennart because we might need to take one of those down first.
Okay.
Maybe he wanted. That's why
Those are TV antennas.
Yeah, they're not even used anymore.
Yeah, it's an old TV antenna.
Yeah.
Could you just tell them on the Discord again to put the other?
Yeah, I don't know where my phone is.
Probably in oh, it's on the table.
Yeah.
We can also probably switch to your phone.
Yeah, I'm trying, but they didn't put us on stage. That's one. Yeah.
Yes.
Let's see here. Is it a better sound here?
Yes, I guess so.
Yeah, just if you turn off.
Joachim, can you just confirm if it's better sound with the other one?
If I say things here, do you hear me?
No.
No. Because this is a microphone, I think. Now?
Yeah, it works fine. As long as you're close to it.
Yeah, I'll put it on David then. Let's see here.
Then I disconnect this one.
Yeah, no, don't disconnect it. You can mute it though.
Yeah, you know what we need?
This is fucking wet here.
No, let's try this one. So you can use this.
Oi.
No, just leave it. I need the camera there.
Okay.
but you need to be close.
You're just connecting me.
You're the IoT person now. So, here we go.
Jo, men det går bra. Vi har inte gått upp än. Tänker skruvmejsel, har du det? Den här.
Yeah, now he put me on the main one. So,
You want to?
the holder, yeah.
Yes. Perfect. Cool. Now it should be good to go.
Perfection has been achieved. David, say something.
Yeah, test 1, 2. Ja, men skruvmejseln hade man ju.
Oj. It's wet.
Ja. There we go. Where's the lid? Yeah, we're gonna need the lid. And I think this should go in. Så här har vi gjort det. IP67 tror jag.
Ja.
Har vi den. Locket, buntband för att fästa på den stången där. Och sen den hade vi. Ja, just det. Den satt inte där. Och sen Ethernet-kabeln.
Let's fix that one and then see if this, because most of the, let's put it the last, because we can take
Which one?
all the cables in, the excess cables we don't need. How far is gonna be from this one?
Yeah, we can decide.
Yeah, so
Yeah, we can decide.
then we can adjust this cable.
Oh, yeah. Oh, you mean, yeah, we put this last. Yeah, exactly. Yeah, that's true.
So let's
Gonna do this. There we go. So that's that, and then we have this. And then we have this.
Okay, let's do. We can go to
Yeah.
the other side.
Yeah.
I give you this.
Yeah,
And then I join you.
just put them here. We can just put them here.
So we can go for it.
So. Ja, de här var lite... De var nog lite längre. Ska vi testa dem istället?
Ja.
Ja. Okej, jag
I think you two can go and then I can join to film.
Ja.
Ska jag bära?
Ja, det skulle du kunna göra. Ja, om du...
Let's see. They're all connected together.
Let me just... yeah, we'll close the lid upstairs.
Let me also go out and then I can grab those. Yeah, give it to me. I can bring them.
Oh, I can have them. Cool. It's fine, yeah. So,
So I can take one microphone there up there.
Yeah, but I don't know which one is, because I think
Connected
this should be DM2,
Okay.
and these are all labeled as DM1.
Let me check. I
They're
can.
all DM1. I
Yes.
think, didn't you have another one?
No, it
In
says
your pocket.
it's 4 of them. No, I
Mm,
gave it to
then-
David.
Yeah,
Let's
then
see.
it's one of these should connect.
Yes.
You have to hold the button.
Let's try this. I think it's this one.
så frågan är hur vi går upp.
Let's see.
No,
You should see me now.
it says it's muted.
1, 2, 3.
No.
Not now. It's blinking. Let me see the other one. Oh, this one is also on.
Which one's blinking?
Both of them. Now we
Yeah,
don't.
but it doesn't connect them.
No.
Nej, men vi gör
Så-
inte det. Vi kan sätta.
Do you see something on top? It's connected. 1, 2,
No.
3. 1,
No.
1, 1.
Ska vi göra så?
Is it on?
Both of them.
Nej, har du dem eller? Ja precis.
No.
Probably it's like the microphone has an issue, one of them.
Yeah. It won't connect.
But
Gå närmare David.
okay, yes. Which one was the other one? Like if I can go.
Yeah, the only one that works is on him.
Okay, yes.
Mm.
Just put my phone here.
It's great that those things are gonna be right. Oh yeah. You have something else in your pocket. Do you wanna?
No, that's okay.
That's fine.
That's cord. It's not a...
Oh my god, I don't know if I.
Ja, den kan vara strax under. Ja, de här. Om du håller...
Ja, det gör det.
Ska vi börja med att sätta upp där? Nej, det stänger jag.
Don't do IoT if you're afraid of heights, right?
Afraid of sleeping.
Oh, shit. Oh my god. David, you have to speak because they only hear you.
Oh yeah, right. I am the one with the mic. Yeah. So
What are you doing?
Yeah, we're trying to install the antenna at the moment. As soon as that's in place, then we're gonna try to also maybe put the gateway, and then we're gonna lead the cables down to one of the rooms. Are we going to take it more? Yeah, we can probably go with this side. He's gonna in here. He's just gonna press it. Yeah. Yes. Yeah. It's not stand on the same bricks. Okay. Yeah. Right now I'm on different.
This does not seem safe at all.
No, it's like they would, yes. Yeah, they like they just mounted like laying on each other. So.
Do they need help there or are they fine?
So, yeah. What about this one? How to mount the gateway?
So this also has, we can use these stripes. Yes. That's all. I think it's the height is enough probably.
Speak, David, speak.
Yeah.
Tell stories about your life.
Stories about my life, I don't know, but the thing is, I think it's probably warm enough to take a swim.
Yeah, that's good.
So we'll go for a swim. Which, I mean, like every year someone swims.
Yeah.
Yeah. Yeah, right. So what we have now, I think the one that we're installing now is a 3 dBi antenna. And what we also have with us is a 5 dBi antenna. So what's the difference between those two?
So the waves could just travel more in the 5. So
I think the higher
should be enough. Yeah, exactly.
Yeah.
The higher, so it's 8 is even higher.
Yeah.
So it could travel with probably 10 kilometers.
Yeah.
If it's in the right spot and if you have like the line of the sight. So probably this one works if it's high enough. And like one side of it, right now we have an issue. So one side of it's a metal.
You have
So
to speak in the microphone, otherwise I don't
Yeah.
hear.
You're gonna have
right now the problem is like one side of it there is a metal. So like when it is pressed, so from behind it just there is an obstacle. So if there is no obstacle, then that's perfect. If we couldn't put it up there, so that's the perfect place. But still, these places should travel. Like for 500 meters, definitely it goes. Because there is no high building, so it's only trees, and also water is a thing that we need to take into account. But between here and there, still there's no water, so it's like that waterfall. So that those could affect the. Be careful.
Camera woman is full.
So we try our best. Let's see.
Yeah.
What do you have to say?
Yeah, I don't actually have to say. But generally, I think the more open spaces, the higher dBi, because then you have this horizontal
so you could travel
coverage behavior. Whereas if you have lower dBi, it's more like a spherical
exactly. So
coverage.
If you're like in, we just talk about like we are in first floor and then I don't know 20th floor. So these one works much better compared to the higher. So those one could travel longer, but they have a like narrower presence zone. So it's really hard to to know that who talks and you don't have to talk. Now it's better. Now it's
That was my turn.
Yeah, I can.
I'll just do commentary. Hi everyone. Yeah, so I'm a bit scared of sitting here. Hopefully they will be done soon.
Yeah, you did a great job. Like,
Yeah, awesome. Yeah, and after this, then we're hoping to install at least 2 sensors. So David talked about swimming because one thing we're interested is in measuring water temperatures in one of the bathing places, swimming spots, beaches, right? And another one is in the fridge for ice cream to monitor it. And then this is just a test. Of course, like the destination Hässö, they are interested in connecting even more sensors and seeing sort of monitoring all the parameters in different houses that belong to the camping site and around the island. But the first step then is what we're doing here is creating LoraWAN coverage because right now it's there are no gateways in this area and we won't get any data, so that's why we're here on the roof. But hopefully, and then today we're also aiming that once we install all the equipment, we check that the coverage works in all the places where we want to install the sensors. So stay tuned, stay connected with us. We'll do this kind of slow TV style, so you can walk away to get some coffee and then connect back to us. I won't stop streaming. We'll just continue. We'll try our best with the microphones. But we brought 4 microphones And just like it is, you know, the demo day, everything goes wrong. So this is the only live microphone with us. The rest don't connect. Don't. What the hell? Yeah. So we'll do our best to pass. That will be my responsibility. So you also hear us, not only see us. And we followed along with your with the 3D workshop. Is really fun. If you haven't paid close attention, please go back to it, because the quiz number 4 will be about 3D printing, and they will reference specifically to the workshop. So even if you haven't tried, you don't have your own printer, you haven't tried it, if you watch the workshops, just the basics, you should get covered. Yes. Now,
Perfect. So
how is it going there with the with the antenna?
let's see. It's going well. We're finished with the antenna now.
It's going well, yeah, but it seems like
Ja, okej, men då kanske man behöver... Ska vi köra med svart på den andra? Yeah, there we go.
Yeah, so now they're attaching it with the plastic strips, it's called, right? So just to fixate the cables. Actually, it will be fun to come down from here. I'll just stay here. Oh, Jesus Christ.
Yeah, usually when we climb up, it seems easier than going down.
Yeah.
You look, okay.
Yeah, never look down. That's the rule. Yeah, but I got like really, I don't know, when I was younger I had no fear. Now I can't even go like on Tivoli, you know, like this rides and stuff. I just this is enough adrenaline for me, going on the roof.
Okay, so I think David, I should go and bring the cap as well.
Yeah, exactly.
And also a screwdriver. Do we have a screwdriver here?
No, we don't need a screwdriver. We can... we do have. Yeah, we do have.
So I probably go down.
No, you can't go down because I'm sitting here.
Then I go from the other side.
Can you do that?
Yeah, it should be possible, yes.
Oh my God, don't slip.
No. Don't worry, I can. Don't worry.
Just hold on now.
Yeah, you can like record me live.
Yeah. For the insurance. So he decided to climb up on his own without any protection. Oi, you okay there?
My mobile.
All right. Yeah. It's like a David's backside here. Very nice. No, it's wait, see that. So is that the case? Is that the case for them? Do you want to take it closer? come in.
Yes, sure.
Get close.
See here. Vadå?
Just trying to show close up what you're doing.
Va? Oh. Jaha. Då är det varmt.
Ja, nu. Okej, men ska vi... Ja, precis. Hur högt upp vill vi ha den? Vi kanske inte... Nej, vi har den längre ner. Den behöver inte vara så högt.
När vi mäter borta vid bron så kan jag hämta verktyg och spänna de här.
Ja.
Yeah, so after this we're going to the bridge, right?
Yeah, I think we're probably gonna take the point that is close to here.
No, okay, so just
to the north, and then we go south.
Okay, so first we test here somewhere.
Yeah. We just need to test that everything is working, and
It's good that we don't need to carry anything down.
Except this phone.
Yes, except this one.
Yeah, so all equipment stays here on the roof. Where does will the power connect? Go down.
Yeah, it goes somewhere inside. Both of them are 25 meters.
Okay,
so it should be enough. Yes, so it should be enough to cover.
And that's with like a weather protected box, right?
Exactly. So it's like
I think IP. What was it? IP 67?
Yes, IP 67. So we just like mount the antenna. This is a gateway, and this is a safety box for the electrical connections.
Kanske kablarna kan vi nog kanske fästa längst ner.
Don't forget to protect the electrical connections with the case.
Vill du ha en till? Vi kan ha längre ner för båda. Både el och internet.
Zip ties. For everything.
Ja.
David, the whole internet will know your underwear brand.
Yeah. So I try to go further, but
that will be the quiz. The quiz question.
It's gonna be one of the quiz questions. Yes. And then for higher grade, you also need to guess how much they cost. So not only the brand, but at the moment of purchase, how much they cost.
Yeah. I think they don't hear from that microphone.
It says that for higher grade, you also need to know the price.
Exactly. Okej, men då ska de här kastas över till andra sidan. Ska vi ta den rutan, den vägen?
Så. Power cables over to the other side.
Vi kör lite cowboy-style här och bara.
Men vänta, vi måste få... Eller har du varit uppe på det taket?
Nej, inte det taket. Det är lätt att komma upp.
So it's gonna go from... You can say that...
Can we climb up on the other side to get the cable?
I don't know.
Some serious lasso.
Jo. Det har jag testat. Jag testade med den andra som du... Ska jag testa?
Ja.
3, 2, 1.
I tried. Oh wow. Almost.
Okay, then I can always pull it back. So.
Annars kan vi ju slänga ut den. Okay.
Yeah. We can go to the other side, but
that one for sure should work.
Now the big one.
Yeah, but I think my shoulder will go with it.
Hold on.
Yeah, okay. But we still need to... No. Ja, men är det jobbigt att... Jag vet inte. Jag har aldrig varit här. Jaha. Wait. Let's do this. It shouldn't... Okay, so just take it as much as here. I think it should be okay. Yeah, here is fine. And maybe we do. Sure. Yes. All right. Okay. Yeah. Now we need to.
Are we going down?
Yeah, we need to.
Oh my god! All right. Let's
I can grab.
Can you?
Yes.
Hold it.
All right. So we are going down.
I can take my teeth.
So you can.
So you're gonna climb to the other side.
Yeah. Yeah, I'm not going there.
Yeah, I'm not going there. Oh my god. You need to be sporty for this job, you know?
Yay!
There's like a thing in the way here. What is behind there?
Oh, but yeah, I can
Oh shit.
give it to me.
No, pass.
Yes. Oh yeah, that's the connector. These are fragile. Huh? These are fragile. Yeah. So fragile. Anyone going on the other side? Yeah, yeah. So can you go down on the other side? Yeah. You need me here? No. I'm actually done here, I think. Nu kan du köra någon sån här cowboy. Lennart, så ja. Kör en sån här cowboy-kast. Ja. Det borde räcka, va? 25 meter. Alltså det är ju, där kan man ju till och med leda lite finare sen. Vadå för något? Roxana, do you have the mic? Yeah, I don't know. Yeah, no, it's fine. Say hi, Mom. I'm on TV. Okay. Yeah, I'm just trying to figure out how that Ethernet cable was this much twisted.
I really thought that I would get it all the way on the other side, because that's what I did with the last one. But yeah, I couldn't do it with this. No, it was indoor and it was surprisingly lighter. This one. Right. Yeah. Yeah, the only thing missing really last time was the horse. But I couldn't take the horse with me up on the roof. All right, so I'm going down now. Huh? Yeah, but do you want me to throw it? Yeah, please. Ja, men du kan inte hoppa där. Ja, snälla. Du är ju...
Like a cat.
Yeah, like a cat.
Aj då.
Ja.
Crash.
Oj! Ja, okej. Det kanske inte vi ska... Ja. Ska vi... Yeah, I'd rather not throw anything. Yeah.
Oh, he's jumping. I don't know, like this. I think we need to. Yay! I think we need to reconnect with your phone so I don't. Battery and stuff.
Yes.
I'm going down. Some window washing here as well. Yeah, everyone is climbing. All right. So now let's see if you can also connect to the stream, and we just hopefully gracefully move over so it doesn't just drop.
See how much battery I have.
I don't know if Joachim hears us that we're gonna do that.
Yeah, I can hear you. I don't know if you can hear me though.
Yeah, there is an app, StreamYard Guest it's called.
Okay. Ja, vi hade 2.
Yeah, I think I took it down. Is it one more?
Det behöver vi inte mer.
Nej, de behöver vi inte. Ja, eventuellt för sensorn. Den svarta, du vet, under bryggan.
Is there a bathroom somewhere inside?
Toa. Toilet?
Yeah.
Yes.
I'll leave you the mic.
So let me call Joachim so I can. Hello. Okay, cool. So the microphone, we know that only one of them. Yes. Only. Usually. Really? So it says, we thought that one of them should work because there are
This one?
You're muted.
Oh, okay.
Can you just... Now it's fine. It's fine.
Hello? Hello, hello, hello. Hello, hello. Wait. So can you hear me?
Is it... No, you cannot? No? No, no. You can... I think it's from the phone.
Yeah.
Probably. Like then...
Can you ask him to send the link in workshop admin so I can join with my phone?
It's in workshop admin.
Already?
Yeah, it's in your admin.
All right.
David is going to join.
Yeah, I got it.
How's everything?
So we're trying to resolve a couple of audio issues for those who are watching the stream.
Okay, yes, it's almost workshop time. So you know what we could do? We could just say that this is like the end, and then
You can hear 2 microphones now?
Yeah, I think it's now it's 2 microphones probably.
but I
Hello, hello. Yeah, I need to move away from it. Yeah. Yeah, I'm gonna move away from this. Can you just hold it? This one? Yeah, it's it's the second one now.
Okay. Oh my god.
Is it working? No. 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 When you get like.
All right, all right. Here's what we're gonna do. I'm gonna unplug it and then. And it should give me an option to choose. External mic. Wait. This is on, right?
I think it's working.
Hamid, can you?
I need to say something.
Okay. Do you hear?
Okay, I think one alternative that we have is that it is soon workshop time. So I think my suggestion is that if maybe we just round up here and I film properly the swimming and the installation of the sensor and we share it as a separate video. Joachim, what do you think?
We're also going to share the coverage map, so and
yeah,
then they can
and the coverage
just
map. Yeah, exactly.
Yeah, watch and keep
because
an
I
eye
think
on the
it will be better if I let's focus on the filming than if I try to do this live.
Yeah, I do.
Yeah. Do you think that's a good idea? Yeah, awesome. All right, guys. I thank you for being with us on the roof and in the lab. It was very nice experience. Hope you tolerated our technical difficulties to the end. Good luck with starting of visualizing your projects this week, and join the workshops to get help with all the platforms. Please watch again the 3D printing workshop that will help you with the quiz number 4. And today about this project, you'll also get a nice video afterwards that we will share about how well we got the coverage, the helium coverage to work on Hässö, and maybe some swimming action as well. So yeah, check back for that in Discord. And thanks for today. Thank you, Joachim, for trying to steer everything. You did a great job. Thank you.
Thank you. Good luck. See you later.
Yes. Thank you. Bye.
Bye. Yeah, so we can take a quick look at the 3D printings before we wrap up. As you can see, the little adapter thingy has actually come quite far along now. And hopefully we'll get to see the result of the casing as well a little later. So see you at the workshop, everybody, and have a great day.